We appreciate you taking the time to join us on this first in a series of webinars that we're holding to focus on GNSS simulation. Just a quick introduction. My name is Jake Blankenship. I'm Orolia's Vice President of Asia Pacific. I currently live and work in Kuala Lumpur, where I've been for the last 4 years. Prior to that, I lived and worked in Singapore and Jakarta and other parts of Asia for over a decade or so. For today's webinar, we have two presenters, or two participants from Orolia USA, Ms. Lisa Butler and Ms. Lisa Perdue. Lisa Butler comes with many years of experience, as well as Ms. Perdue. So we're very fortunate to have both today. In summary, we're going to cover three primary topics. First, hardware in the loop. Next, we'll talk about multi-antenna and vehicle use cases. And lastly, RTK testing methodologies. These are critical applications for GNSS simulation, and hopefully they're applicable to the work that you're doing. And we appreciate, again, you taking the time to join us. We hope that you find today's webinar useful. And without any further delay, I will turn it over to Ms. Butler.
To kick it off, we will start covering the topic of hardware in the loop. So I'm going to just jump right in here and let's do a quick definition of, what is hardware in the loop. So if you're aware, whoops, sorry, I think I switched the wrong, there we go. My system is sensitive there. Okay, so hardware in the loop is typically, you'll see it as HIL, so, HIL. Or sometimes you'll see HWIL, but typically just HIL is what you'll see. And really, it's just about real-time testing. And typically it does include, we're talking about GNSS today, or GNSS simulation. But typically in hardware in the loop or HIL testing platforms, you'll have other, sensors and signals included in it. So it's typically a system of a lot of different signals included, but real-time, testing going on. Wow, this is really sensitive. Apologize, everyone. All right, so if we look at a HIL system with a Skydel-based simulator, and Skydel is Orolia's newest platform. It's actually been out for several years, but it's our flagship simulator. And if we look at a system set up here, what a HIL platform would be is sending in commands, so position commands in real time to the Skydel-based simulator, or any simulator for that matter. And based on the input, the simulator will generate satellites that are in view based on that data. So if you're going to, stop, accelerate, turn left, turn right, those kind of commands. Based on that input, the simulator will generate its, satellites in view, send those via RF to the receiver. And then while that's happening, the data, the NMEA data that is logged within the receiver will also be sent back to Skydel. And so Skydel can actually measure position accuracy, position error, that sort of thing. And then you'll see, we'll talk about this a little bit more in another slide, but excuse me, there's a clock, time synchronization of the two systems together is very critical in hardware in the loop. So if we look at a real case scenario, this diagram is courtesy of DSpace, who is a leader in the automotive and space and other areas of HIL. So this is their diagram. But I will say Orolia and the Skydel simulators work with all sorts of HIL systems. So keep that in mind. But this is a great example of a typical use case. So if you look at the HIL simulator, which is the background in blue, it is what is driving the whole system. So it has the test platforms. It's sending the signals, the vehicle trajectory, the motions. So whether you want to, like I said before, accelerate, stop, turn left, turn right, whatever motion you want to do, it's sending it in real time to the signal generator, the GNSS simulator, and then it can send the RF to the device under test. Now, You can also run scenarios and do other things from a HIL simulator, just depending on your setup. But, you know, the HIL simulator is typically a different device driving the GNSS simulator to do, you know, take action. And again, as we mentioned before, you'll often have other signals included. So whether it be CAN bus or sensors or radar, LiDAR, whatever it is, all done in real time. So also common, you know, that was an automotive introduction. Also quite common for HIL is a flight simulator. So, you know, if somebody were using like a joystick or a flight, you know, flight controls, and they're pulling the aircraft up, they're banking left, they're banking right. These are actually different motions than a vehicle, right? Because a flight has a different trajectory. It will kind of do the same thing, right? Based on your real-time inputs, the flight simulator will send that data to this GNSS simulator, and based on that, it will generate the satellites that are in view. Now, it might be very different. You know, if you're doing a a spacecraft, you know, you could be seeing many more satellites in view because you're looking over the horizon, or, you know, depending on where you are in the atmosphere. So it makes a big difference on the type of trajectory, the motion that's being input. And so because of that, the iteration rate, those type of requirements will change based on the use case. So in a flight simulator, having the 1,000 hertz iteration rate is much more important because you're getting much quicker, you know, updates, position updates, or you can potentially receive much quicker position updates in the simulator. So in that sense, the iteration rate will be really critical. So if you look at these systems, you know, the HIL simulator on the left in green, talking to or sending position to the GNSS simulator. What's critical in these systems is that they're time synchronized, that they both have the same, they're getting time from the same source. Because otherwise you could have, you know, a very secure, stable time reference in your simulator or in your HIL simulator. When I said simulator the first time, I meant GNSS simulator. But if they're not synchronized together, they could be drifting at different rates, right? And that could potentially cause problems in your complete HIL system. So this is a critical factor, and this comes up a lot with our customers, is sometimes we'll find out customers are having some challenges because they need to have a whole system time synchronized. Now, Orolia, that is one of our expertise. You know, we are experts in GNSS simulation. We're experts in PNT, actually, position, navigation, timing, but within that is timing. So in this diagram, we have the secure sync at the top in gray. It could certainly be a reference, but if you had another reference that you use, then that could also work in your system. The other factor that's really important in a HIL test platform is the simulator latency. Now, what dictates what latency is required is your use case. So, you know, for example, if you're looking at a automotive crash avoidance system where, you know, you need to apply brakes based on something that's happening, whether it be a pedestrian that's crossing the street, a vehicle in front that, you know, crashed, and you need to apply brakes so you don't crash, and you want to test this type of scenario in your HIL setup, the latency is really important because you cannot have any delay. So your use case will drive the latency. Now, I will tell you, Orolia has a whole family of simulators, and our Skydel latency is, the optimum latency is about 5 milliseconds. our other simulator does not have as good a latency. So while it might work with some systems, it wouldn't work with a system that requires this great latency, this really low latency. So, you know, that's something to keep in mind when you're putting together your HIL system, is what your test requirement is, so you know which simulator, what kind of specs you need to meet the needs for your test platform. So one way, you know, one of the ways that the way that Orolia works, or Skydel works, I should say, is when we take in the commands. So we were talking about the HIL commands being sent to the Skydel simulator. Those are position, right? So, you know, turn left, stop, it's accelerate. We timestamp those very tightly, and with that timestamp, then we can, there's a buffer, we can actually optimize that and change those settings to make sure that the latency is both optimized. You don't have jitter, you don't have, you can control the like stability and the optimization of your entire system. So that, not all simulators do it that way. In fact, I mentioned Orolia has some other simulators. In those simulators, we use a synchronous approach or a traditional approach. In that type of HIL system methodology, you're doing something. When you're synchronous, your approach is synchronous, you're basically sending in data at the exact same time you want it to be simulated, basically. So there's just this immediate, you want this immediate exchange. There's nothing's timestamped, and you could potentially have jitter. And that jitter could potentially change, right? Because maybe depending on what's happening with your system. In the Skydel system, we use an asynchronous approach, which means basically we're timestamping. So we use the timestamp approach to control the jitter and make sure that we have deterministic latency, so we know what it is and we can actually compensate for it. So just to know, there are different methodologies out there. They have, be aware of that when you're working with a simulator, and that can help you determine the best way to optimize your system. So with the Skydel system, we have in our platform, the Skydel is our software platform. So the Skydel platform works within our simulators. One of our models is called a GSG-8. We have a feature called this real-time performance measurement, which is, excuse me here, which is a feature that is included at no cost with the Skydel platform. And it's used in the HIL systems that we've been talking about, and it's used to optimize your latency. So if you have a tight requirement, you require less than 10 milliseconds latency, for example, this HIL and this real-time performance measurement is a great tool for you to verify that your whole system is behaving the way you expect it to and the way you need it to. And so it basically gives you a peek into the whole system. And when I say whole system, I do mean the whole system, because GNSS simulator is typically just a part of it, right? So you can see if you're inputting your HIL system is inputting data into the GNSS simulator, you can see how those behaviors are working together, and allow you to get as close as you can to your latency limits. And you do that by your settings, right? So there's some settings in Skydel, for example, that allow you to set your latency and your delay. So when you're timestamping, if you're sending in a signal and you're timestamping it, you may want to send it, you want to send it before the simulator sends its signal out, so you can set all those settings out and optimize it so you have the lowest latency possible. So I'm going to go to a different slide and then come back here. For those of you who have seen our software, this is kind of a glimpse of it. If you haven't, this is, or if you have, this is going to look familiar. But I apologize, this image is not great when it got blown up on the screen, but the orange circle here on the left is basically the performance tab. So when you go into Skydel, if you're just starting a test, you can actually see while you're running a scenario or a test during the HIL platform, there's this performance tab and you can click on it. And then what would open up is on the right, and it will show you what's happened over the whole minute and then what's happening each second. And what you'll see is if we go back to this slide, it will show you if you're having, stable performance, it will stay flat. And there's some other indicators, more detail that is included in this. This is just a screenshot. And then obviously if you're falling behind or catching up, it shows you all this so you can make adjustments as needed. Orolia has a fantastic video on this. It's a 6-minute video that I recommend you guys all take a look at it when we're finished with this webinar or another day. There's a link here, and it goes into great detail on this performance measurement tool and how it works and what detail you receive out of it. So anyway, it's a great tool for those of you doing HIL that have low latency requirements. So what else do you need to consider? I mean, it's really more details about this when you're looking at a HIL system is obviously what is your use case? So based on that use case, what's the acceptable latency between the HIL simulator and the Orolia GNSS simulator? What's your budget? What's too little? What could cause issues? What's the clock that you need? What are you using? What kind of time synchronization is needed? All those sorts of questions are things that you can ask yourself as you're putting together the system. And of course, Orolia can help you with that when you need a simulator or GNSS signals in it. We can help you identify what's needed in your system and how to make it optimized. So why Orolia or why Skydel? Again, Skydel is one of the flagship simulators for Orolia. If you need low latency, the Skydel system is excellent. And of course, we have the real-time performance tool to help you. We didn't get into all the details of Orolia because we only had 30 minutes, and so we're covering a lot of detail today. But the Skydel platform is very user-friendly. It was actually designed for integration in mind. So it was designed to work with other platforms, including other HIL platforms. In fact, if you look at the points below, we've had customers tell us that they've integrated multiple simulators in the past, and the Skydel simulator was actually about half the time of other simulators. So it's very user-friendly. We've also had HIL experts tell us that, yes, it was very easy to integrate, even easier than our 5 and 6, which is also quite easy to integrate, but Skydel was even better, and the latency met all the requirements. So anyway, it's a great platform. And then the other thing is we have all the library codes. We have a library with all the codes and examples. So whether you work in Python or C++ or C#, we've got examples for you to make it easy for you to get up and running. So just a couple highlights there. But if you have HIL requirements, there's a gamut of requirements that you have, and each customer is different. So, let us know, come to your regional sales manager at Orolia and see how we can help, or whoever you work with, with Orolia. Let us know what your requirements are, and we can help you with the right simulator fit. time synchronization is critical for the success of your HIL system. So, keep that in mind. Understanding what latency you need based on your user requirement or your application is very important. And obviously that drives what simulator is the right fit. Please take a look at that 6-minute video. It's really a great tool for seeing how that performance tool works. And then if you we've been talking about a couple of different simulator models, and before I introduce them to you, so I wanted to take a shot just to introduce them very quickly here. The GSG 5 and 6 on the left are what Orolia calls our essential simulators. So anything from, production go, no go to validation, time to first fix, e-call, a variety of test platforms that you can do. It's a small box. You can move, put it on your lap, your own desk and work away. Then we also have a portfolio of products that are controlled by our Skydel engine, and that's really the flagship product. That's the one we were talking about that has the performance, the real-time performance monitoring tool. It has the really low latency. It has the 1,000 hertz iteration rate. So there's a whole portfolio of products that work on that platform as well. So we pretty much have anything you want depending on what your needs are. And then there's some resources in here. So again, you'll get this these slides when we're finished, or this PDF. So there's different case studies and videos and access here. So if you need to review anything more on your own, there's resources here. And of course, you can reach out to Orolia's sales with more questions if you have any. So the other use case that we're covering 3 use cases today, or types of testing, I should say. So the first one was HIL. The second one is multiple antennas or multiple vehicles. So if you just joined, just as an FYI, everyone's muted, and you can submit questions in the questions tab, which is on the right of your screen. It has a question mark above it. So feel free to send those, write your question in, and we will do our best to answer it. But when we're talking about multi-antenna or multiple trajectory, what we're really talking about is, here's just a couple examples. There could be more use cases than this, but the first one is dual antenna. So you have a device that has a receiver with 2 antennas. And you see this a lot in drones or automobiles for heading. So maybe you're sitting still or you're hovering, and you need to know what direction you're facing. So that's a common use case for having 2 antennas. So that would be a multi-antenna example. There's also, we talked about this in the HIL section, but crash avoidance. So you have 2 vehicles driving towards each other, or one stops immediately and the other one's driving behind it. You need to deploy your crash avoidance technology, but you have 2 vehicles driving at different speeds, different trajectories. That's another use case. Another one, which we'll be talking about at the end of this session, is RTK, where you have a base and a rover. So you have maybe a tractor that's moving and a base that's sending out correction data. Those are 2 different trajectories. Or a space station that's docking. So you have a space vehicle that's docking into another vehicle, and again you have 2 different trajectories. So what we're talking about is a simulator or a test need that needs 2 different signals at the same time. That is becoming more and more common. So, if you're going to do testing with a GNSS simulator, you might just be asking, what is my use case? What am I trying to do? Is it a single receiver with dual antennas? Is it multiple vehicles with completely separate trajectories? What is it? If it's a receiver with dual antennas, typically we're talking about conducted testing where you have an RF cable directly from the simulator to the device under test, because this isn't something you can test effectively over the air, right? Because over the air, well, one, you don't have control over it and it's not repeatable, but everyone's receiving the same signal in that situation. So if you want to send a controlled signal to different devices, then you need to have conducted testing. So, just those are just some questions as, maybe you're testing. So how do you do that? So there aren't a lot of simulators, to be honest, out there that can support multiple RF or multiple trajectories, multiple signals out of a single simulator. So in fact, in Orolia's portfolio, some can and some can't. It just, depends on which simulator you're looking at. But if we're looking at the Skydel system, our flagship simulator, we have a feature called multi instance, or the actual feature or the option is called Sky Multi. And basically what it does is you have a master Skydel version. So you have the platform, the engine that runs Skydel, and then you can have slave versions of that Skydel platform that you can control. And you can have multiple instances of that Skydel platform to control the different motions or trajectories that you want within that one system. So if we look at this is maybe a little better or easier image to understand. If you look at, let's say we're talking about the GSG8 simulator, and you have your Skydel instance, open up, you can then open multiple other instances from the same platform. Now, in the GSG8 model, you could have 4 total, but you could build a custom system and have more if you need. And what this means is if you have a trajectory, or a test requirement where you need to control, multiple devices, or you have an antenna and you want to send, you have a receiver with dual antennas and you want to send separate signals to them, you can do that from one platform. So, an example of that would be, sorry, one second here. An example of that would be, we talked about this in that first slide, was, collision, like crash avoidance systems, proximity alerts. You're coming up to a parked vehicle or a stopped vehicle, drone formations, that's a big one. Any trajectory really that you need multiple devices, you could see this in. But just a couple of use case examples of where this might be needed. And then this is a great example. So if you look at this, let's say you have a spacecraft on the right and it has 2 antennas. So antenna 1 and antenna 2. If you look at, let's say, the GSG8 simulator, and the model doesn't necessarily matter, but it's just that one instance. So let's say it's the master instance. You can go through one RF output and send a signal to antenna 1. And through the second instance, you can send a signal to antenna 2. And you can vary those signals. So, whatever that change is, you can control that within the software platform in one device. So you do that through the Sky Multi instance, and we mentioned in here that it's cost effective. The reason is you're literally duplicating the simulator capability in a single box. So you're basically saying, you know what, I want a second simulator within this hardware platform to run these two separate tests. And so you add this feature to do that, and boom, you've basically replicated the capability with all the licenses. So, let's say you have your spacecraft is GPS L1, Beto B1, and let's see, a Galileo E5 and E1. Let's say you have that Sky Multi, you replicate all that, and then you can send all those signals to, your two different devices. So I wanted to kind of share this because it's interesting. I mentioned earlier that not every simulator can support multiple trajectories in a single box. In fact, we had a customer last year, a longtime customer who has many of our GSG5s. That's one of our simulators that's been in the market for about 15 years now. Great simulator, but it can only support one RF. It has one RF output, and it can only support one trajectory, right? So one device, one antenna per simulator. And this customer has drones. They're a commercial drone manufacturer, global commercial drone manufacturer, and their drones were being upgraded to have two antennas on each drone. So they're adding at their facility 2 test benches, and they needed to be able to test these drones that had 2 antennas. So as we mentioned, their 2 options were, okay, we've got a couple GSG5s, we've got 2 GSG5s available. Can we upgrade those and support these new test benches? Well, yes, they could upgrade them, but they still, if you wanted to test, if you even look at like this platform, this is, it would be this type of system, this type of test environment where you would have 2 antennas. So our older simulator, the GSG5, you would actually need 2 GSG5s that are time synced to be able to test this. So we'd have to add a time source, 2 GSG5s, one for antenna 1, one for antenna 2. And then for the second test bench, we need to do the same. But if we just had a Skydel based simulator, we don't need the time reference because we can use the GSG8 with the Sky Multi and control and send signals to each antenna 1 and antenna 2 from the same simulator. And what was interesting is we ran the numbers for this customer and found out, even though they already had some GSG5s, it was actually more cost effective for them to go and just start over with GSG8s. So just wanted to share that example because it's a great example of how cost effective this capability is. It's not only technically advantageous because you have one simulator, you don't have any issues with time synchronization. You can, control everything from one box. It's user friendly. There's a lot of advantages there. It's actually cost effective to do it because you don't have to duplicate licenses over and over and over again in a box. So just want to share that example, real case example with you on a Orolia customer who was upgrading and actually found it better to move to our new platform. So In closing, this is actually becoming quite popular. We're seeing this a growing need. A lot of new customers have simulations where they need to support multiple antennas on one device or multiple trajectories. Many current customers are upgrading. And the good news is, we can help. Even if you have to go to a new simulator, it can be very cost effective. There's ways to do it in an effective way that are cost effective. Obviously, I just said that, but cost effective to get you into a platform that can support these test requirements that for multiple antennas. So again, if we, just in case any new people joined us in the last 20 minutes, the Orolia portfolio is vast. We can support anything from basic go, no go, all the way up to anti-jam, SERPA type of testing. In the multi-antenna area, what we were just talking about, really the best fit is using Skydel, because Skydel has the capability to do the multi-instance feature, and then the GSG-8 model actually can support up to 4 RFs or potentially 4 trajectories or independent devices. Now, one thing we didn't talk about here that you could also do with Skydel is build your own simulator. So if you had your own GPUs or your own SDRs, you could actually build your own using the Skydel platform, and an Orolia salesperson or apps engineer could support you and show you how you could do that. The example I was just talking about with the drone customer who had some Orolia simulators that had to upgrade them, they had this one on the right, I'm sorry, the one on the left, the GSG-5. So this is what they had that only has 1 RF, and they would have had to have 2 devices to support 1 device under test with 2 antennas. So even by upgrading to the GSG-8, it was cost effective. So on here, we actually have some more resources. So if you have, these are actually different resources than what were listed in the other, the previous session. So if you get this entire slide deck, you'll actually have multiple resources that you can look at on different topics. So if you go to our website, you'll actually find a lot of information, but some of this will take you directly to it.
Yeah, actually, there was a suggestion to talk a little bit about the 16 output system that we have versus the other systems which can be limited to 2 or 4 outputs. Skydel can support quite a few, which I think plays well into things like certainly the multi-vehicle, multi-instance, multi-antenna systems that you were just talking about.
Could you repeat the first part of that question?
Just the fact that we support multiple outputs, say up to 16, and how that could be useful to different testing environments, say either in doing vehicle testing, RTK. Well, we're going to talk about RTK next, but maybe that's a good lead into that.
And did you say something? I'm sorry. Did you say something about 16?
16 outputs, yeah.
Oh, you're talking about like the wavefront.
Yes.
Got it. Okay. Sorry, I was making sure it was not talking about channels, just to confirm the difference. So, well, there's different use cases. So maybe we'll spend a little bit of time walking through the portfolio here. So if we just look at the left real quick, you'll see a GSG 51 and 61 and a GSG 5 and 6. So basically what those models are, those have been formerly were also called the Spectracom simulator. So if any of you are familiar with that, that's what that model is. Again, it's about the size of it's a half rack width, I think 4U high, pretty, smallish simulator. Everything's self-contained. It has a front panel, as you see. And the one that has the one in the title, GSG 5161, those are just go, no go. You send one signal, one satellite, you verify if your device under test received the signal, and then you move on. And it's typically in production test. The GSG 5 and 6 are we didn't go through this. Actually, we are going to go through this in the are we in it? No, sorry, but I'll talk. This is the more traditional methodology of a simulator where you use FPGA modules. So it's basically you have hardware, you have channels in it. So you define, you can go up to, let's say, 64 channels or up to so many channels. And by channels, we mean satellites and, satellites that you see and signals. So it's a very different architecture than the Skydel simulator. So just, so we have the GSG 5 and 6 that is, used. It has been used traditionally for some automotive and those types of applications. But if you go into the Skydel model, it's a software-based architecture, which means, and there's some really great resources of this on the Orolia website, which we actually have links to in the resources. But basically what we mean by that is Orolia has focused on the software. So for example, instead of doing the processing in FPGA, we do it in the GPU, which means now we have the processing power of a GPU, and we can do all-in-view satellites. And what that means, if you're in, let's say, somewhere where you can see 12, where you are 12 GPS satellites, you can see 12 Beidou satellites, you see 8 GLONASS satellites, those really start adding up. And then you add L1, L2, L5, all this. So you get all that power in the Skydel, and you have a very realistic simulation. I see, Lisa, are you wanting to add anything before I keep going?
Oh no, just go ahead. I was just going to talk about more about multi-instance, more about multi-output system. So, we had that one customer where we did 16 outputs because they wanted to test their radio systems. So each one of their radios needed a separate GNSS signal into each radio with separate trajectories. Otherwise, if they just took one simulator and split the signal with the splitter into 16 different radios on their maps and on their software, all of the radios would show up at the same location, which is not what they wanted for their demo and display purposes. So they were able to put together with us, we worked with them to put together a Skydel-based system with hardware that supported 16 different outputs. So even though we talked here a lot about GSG 8 and its possibility for it to have, support 2 antennas or up to 4 signal frequency antennas, that doesn't mean that Skydel is limited by that. In most cases, Skydel is limited by the hardware it's running on. So we can increase the hardware, increase the processing power, use more radios, and still from a single system, be able to handle multiple trajectories. And, like I said, we did 16. There's no reason that 16 is the limit. That's just what this customer needed. We could even do more. So just consider that, we're talking about many, many outputs, many, many multi-instances. So when you start to put them all together like that, it can be really cost effective. Rather than in a previous life, we would have had to use our GSG 5 or GSG 6, and we would have had, in order to provide 16 different trajectories, 16 different radios, would have 16 different simulators that would all have to be synchronized. We had to make sure that everything is, well in sync. It's not necessary anymore. We can just use a Skydel-based system.
Yeah, it's a great example. And maybe just to add, that particular use case was for the customer had equipment they wanted to demo. So they wanted to be able to demonstrate this high traffic simulation to their customers and help them sell their product. So it was actually kind of a unique situation, but Yeah, so they might have some vehicles parked, some driving down the streets, you know, different applications, and you can simulate all of that, like Lisa mentioned, from, you know, Skydel, and you'd have multiple instances, and in this case you could have 16, you know, 16 of them, and simulate that all from one, like, you know, platform.
So we do have a question. The first one is that about time sync. So time sync is critical. They're asking if that means the sync accuracy or just that they have to be synchronized. So I'll just say that it's going to depend on the application. If you're trying to provide two inputs, so two antenna inputs into a single receiver, the time synchronization needs to be very, very tight because the same receiver is processing the signal from both of those outputs. So in the case of two simulators, if there was even a little bit of time inaccuracy between them, the receiver would see that as error, and then it couldn't reconcile what it's receiving from one antenna with what it's receiving from the other to come up with the actual navigation solution. So if you're doing something like I explained with the 16 different radios or 16 different devices, then you still need to synchronize everything because you want everything to be showing up, you know, the same time of day, the same, you know, area, but it's not as necessary to have it very, very accurately synced. So it's not nanosecond level sync that needs, because they are actually independent receivers processing it. So it's going to depend on which what application you're using it for, whether it's a single receiver with multiple antenna inputs or it's a multiple receivers with multiple antennas, of course. That will affect how accurate of the time sync has to be. But when you're talking about putting it within one system, like a Skydel system, the time sync is pretty much handled for you internally, right? It's part of the system. The synchronization is done. Like in a GSG8, you know, all four radios are synchronized together internally. So you don't have to worry about externally synchronizing them when you use that type of system.
So, you know, if you look at this image right here, Orolia simulators, you know, we talk about the GSG8 or Skydel. The truth is we can do a lot of, you know, we have a lot of options. So, you know, I guess I would say if you have a requirement, let us know what it is, and, you know, we can see if it's something that can be handled in the GSG8 or if we can build something custom, because Skydel is designed to really handle a lot. We just have to decide what hardware goes with it. So there's just a lot of flexibility. All right, so with RTK, RTK stands for real-time kinematics, or RTK, and really what it's used for is it's to improve position accuracy, right? So, you know, to a standalone GNSS receiver. So if you need like centimeter level accuracy, we see this in, you know, precision agriculture, different applications, then RTK is one of the technologies that's used to receive that. And what you're getting with RTK are correction messages, and those are RTCM messages, or the correction messages that are sent. Now, what's not listed here, in addition with RTK, you typically also have multi-frequency. So typically an RTK receiver is going to have, you know, work with L1, L5, maybe L2, I mean, multiple frequencies. So, you know, remember that as well. But just to, you know, an example of what it might look like if you had a, you know, a high accuracy, you know, receiver. There's multiple receivers out there that support RTK. This is just one example. And it would receive signals from the GNSS satellites. So whatever constellations and frequencies it supports. And then also RTCM correction data from the base station or the reference network. Typical use cases for RTK, I mean, it's really runs the gamut, but anywhere where precision positioning, so like centimeter level positioning, is required. You know, we see it a lot in automotive or autonomous vehicle assisted driver type applications. So ADAS, you know, applications. We see it in precision agriculture is a big one. You know, survey equipment, mining equipment, space launch. drones. There's, I mean, really quite a few use cases. So it really, you know, if your receiver can support RTK, then you need it. So there's a couple different ways to test it, but really the key is if your rover or your receiver is receiving RTCM messages, then you want to obviously replicate that in your test environment, right? So there's the main two ways to do it are how do you get the RTCM messages? Are you getting it from the simulator, or are you getting those RTCM messages from the base station? So if you want to look at that kind of in a diagram, if you look at the left, so if you as the user, you know, you have a receiver with RTK, and you want your the simulator that you have to provide the RTCM messages, then in this situation, the GNSS simulator would provide position via RF to the rover or your receiver. And then it would also send RTCM correction messages via like serial. So that's one application. Now, if you have access to the base station, or you're deploying a service, or you know, you have both the base station and the rover, then you may have a different setup. So there's really two ways to do this. The middle one, method 2, is if, you know, we talked in the previous section about multi-instance, right? A simulator that can support multiple RF outputs, right? Or multiple trajectories. If you do not have that capability and you can only do, you know, one signal or one trajectory per simulator, then you need to go with the middle configuration. So your simulator, you know, one simulator sends an RF to the base station receiver, and then your second simulator sends an RF to the rover receiver. And those two simulators are then synchronized, which we were talking about with a time source. You always have to synchronize them if you have two separate simulators working together but independently, if that makes sense. You always have to have a separate time source. So if you send those, you know, the signal to the base station, the rover, then in that situation, the base station would send the RTCM correction messages. So there's one application. The method 3 is if you have a simulator, like we've been talking about with the Skydel simulator, that can send multiple trajectories or has multiple RF outputs, and you can send that from one simulator. So in that sense, if you have the base station, you could have the simulator send the RF to the base station, the same simulator send the RF to the rover, and then receive the RTCM messages from the base station. And again, it would be sent like over serial. So now Orolia really can do all three of these, but you know, the most common are method 1 or method 3. A lot of times customers don't have, you know, the base station, so the only way they can receive the RTCM messages is if it is provided by the simulator. And I believe these are the MSM3 messages. Those are the common messages that are used and that are sent from the simulator. So to give you a diagram, if we look at the GSG-8, and that's one of our simulators. So if you are looking at method 1, so if we just go back to that real quick, method 1 where the simulator is sending the RTCM messages, what it would look like in theory or in practice, the simulator is time synced in itself, right? Because it's a single device, so you don't have to have any external time source. Wow, that was loud. My watch just started talking to me. So in the GSG8 or the simulator would send, the RF signal to the device under test and would send the correction data, the RTCM correction data via serial. So that would come, off a single device. That could be supported within the GSG8 simulator or any Skydel simulator for that matter by using the Sky Multi that we were talking about earlier. You would need that because you would need to send a separate second signal. So you need the Sky Multi. And then you would do something called Skydel uses a technology called our plugin technology. And through our plugin technology, we can support the RTK or the RTCM messages. So you would add those two features or those two options. And then whatever required signals you need. So if it's, GPS L1, L2, L5, Beto, B1, B2, Galileo, E1, E5, you would add all those signals, or you'd replicate those signals with the Sky Multi and then support with the RTK or the RTCM messages. And those would be automatically sent based on the position of your base. So that's one option, and that can be supported. The second option would be if you, the customer, you have the base station. So you have both, and you want the simulator to send the signal to the base station, and then in this case, the base station would send the correction messages. So again, you would still need the multi feature. The GSG8 would be sending two signals, but the base station, since it's sending the RTCM messages itself, you would not need the plugin, the virtual RTK feature. Now, if you have proprietary RTK capability, that is something that simulators really can't support because there is proprietary systems out there. This would be one way to do it. So if you had your own proprietary platform and you wanted to test it, this would be a great way to do it because the simulator, would then just send the signal to your base, right? And you could work within your proprietary platform and still get some testing out of it. So we have customers that do the RTCM. They want the simulator to simulate the RTCM messages, or we have customers that have the base and all they need is us to send the signal to it, and then they generate the RTCM and send it to the rover. We do have both systems deployed, and we can support both systems in the field. So it's just a matter of understanding what your need is, and then we can configure the right solution. And I will say, maybe just since we have some extra time here, this has gone a little bit quicker than I planned, is that we had one customer that had the base station as like we're looking at here, but they also had a dual antenna. So they had a device with dual antennas and multi-frequency. So if we think about that in the way that our system is deployed, that required 4 RF outputs. So won't get into all the details on that. We can actually, if a customer wants to learn more about that, you can contact us, or if you want us to dig into that more now, we can. But and they needed to keep they couldn't add more RF outputs for multiple reasons. So they decided to deploy Orolia's capability or Skydel's capability to support the RTCM messages. So we used the multi to support the second antenna, and then we used the plugin to support the RTCM messages. So we were actually able to do multiple use cases, multiple testing use cases by the flexibility in our device, in our simulator. So there's a lot of different capabilities out there. So really, whatever your application is, whatever your test requirement is, we do have the capability to do it. We can test all the signals that are, out there. It's just a matter of what your need is, whether you need whatever diagram you need of this, whatever your test methodology it is you need or you have, just let us know. We can configure the simulator to meet any of these needs. And we can support all the different signals, all the different frequency bands. If you need something beyond this, you even need more RF outputs than this. As Lisa mentioned earlier, we actually can do it. We just need to, we have the software capability to do it. We just need to design a slightly different hardware platform or work with you to design that, and that's not a problem. So we can do that as well. Yep, I think we just talked about all this, that if you have this capability, just let us know your methodology, test methodology, and we can work with you to do that. With RTK, we actually can support it on either the GSG 6 or GSG 8, or we can use Skydel simulation engine to do something custom or work with your hardware platform to test it. So we actually have multiple platforms to test and work with RTK testing. So are there any other questions about that? We also have resources available here. One video that we have that's fantastic that's on our website is by Lisa Perdue, who's our director and was talking earlier. And it talks about the whole methodology around the Skydel platform and around using SDRs and GPUs and what we mean by that. And really what flexibility that gives us and what capability that gives us. And so if you want more information on that, we've got some great, they're 180, 360 and 180 basically means a 360-degree view in 180 seconds. So it's a quick 3-minute video. There's 2 parts, so it's a total of 6 minutes, and it gives you a lot of background in the methodology of the simulators and the Skydel simulators and how they work.
So we did have one question come in on RTK. So the question was for RTK, there are 2 kinds of correction messages, OSR and SSR are both available. So right now what we support is the MSM messages for multi-GNSS. So we're not currently supporting the SSR messages, but we can. I mean, we can add that to what we do. We just need to understand the use case and what messages are needed. So it's one of those things where, we're ready to do it when you have a need for it. So just, reach out, let us know, and we can work with you to get those messages that you need added into the system.
No, that's great, Lisa. I think that is a good example of how flexible the platform is. As these requirements evolve, as 3GPP evolves, as CAT testing for telco, and all these different applications, Skydel is really well positioned to be quickly adjusted to meet those new requirements. As new signals come in, we added QZSS very quickly to Skydel in a matter of months for a customer that needed that. So we have this really flexible, very usable, scalable platform. And we're really interested in following up with folks who have applications, meteorology, big ag, space, and talking more about what their specific needs are so that we can build out on this platform that we have. Again, I'd like to thank everyone for participating today. We will follow up when the meeting ends. The link becomes available, I believe, to all the participants. Also, we're going to follow up with our partners and customers with some key takeaways, a couple points to consider, and we really hope that this becomes a dialogue that we have with you on your journey as you develop needs for GNSS simulation. We can hopefully be your provider for doing some of those activities. So with that, I will say goodbye and thank you once more. Everyone have a great day. And thank you both, Lisa Purdue and Lisa Butler, for everything that you did. I think you made it a great success for us.
Thank you.